Hi all, welcome to the new session of previous year question paper discussion of physics from the chapter Light, Reflection and Refraction. Now we are going to the questions. Now our first question is, upper half of a convex lens is covered with a black paper. Draw a ray diagram to show the formation of image of an object placed at a distance of 2f. So the question is based on a convex lens and the object is kept at a distance 2f from the lens. Mention the position and nature of the image formed. So we know that here object is at 2f. So image will be at 2f. So you know that nature of the image will be what? Real and inverted. Size will be same size the image. Your question is, state the observable difference in the image obtained if the lens is uncovered. So if the lens is not covered with a black paper, what will happen? So what observance or what thing you can observe? So we will consider the case of a convex lens. So now this is our convex lens. So we can mark the position, let it be f1, let it be 2f1 and let it be f2, let it be 2f2. Now we can keep the object at 2f1 or 2f as per the question. They are telling to keep the object at 2f. Now you know that as per our rules to draw the ray diagram, first rule, a ray coming parallel to principal axis after refraction passes through the focus. You know that here image want to form at 2f. So now we can mark the position to get a correct image at 2f. So now again we are using another rule. That means a ray passing through focus after refraction goes parallel to principal axis. So this is the case when there is no black cover in the upper part of the convex lens. Now you can see that here image will be formed at 2f and the nature of the image is real, inverted and size, you know that same size the image. Object size and image size will be same when the object is at 2f in the case of a convex lens. Now your question is, upper half of the lens is covered with a black paper. That ray diagram you need to draw. So now we can consider this upper part of the lens is covered with a black paper. So now this part of the lens we are covering with a black paper. So you know that there is no way to pass light ray through this upper portion of the lens. The light can pass through only through which part? Lower portion of the lens only. So you know that upper part no light ray can pass through and reaches to the other side, whereas light ray can easily pass through the lower portion. That's enough. That lower portion is enough. All the light ray from the head and tail of the head and tail of the image will reach us on the other side. What is the observable difference? Here you can see that both the portion light ray can easily pass when there is no covering. Both the portion light can easily pass and a bright image will form at 2f. But when it is covered, upper portion of the lens is covered, what will happen? The brightness of the image will reduce. So the answer will be what? What difference we will observe? Brightness of image will reduce when we covered with a black paper. So your question is what? State the observable difference in the image obtained if the lens is uncovered. So your question is if the lens is uncovered. So if the lens is uncovered, you can see that a bright image will be formed. Brightness of image will be reduced if you covered with a black paper, and if it is uncovered, you can see that a bright image will form. So a bright or intensity will be very high when there is no covering. When there is a covering, you will get exact image, but the intensity or brightness of the image will get reduces. So how can you draw that ray diagram? So we will draw the first case. So we are drawing a convex lens again. Now, as per the question, upper portion of the lens is covered with a black paper. So now let it be F1 and let it be 2F1, let it be F2, let it be 2F2. So we can keep an object at 2F as per the question. So you can see that the light ray cannot pass through the upper portion of the lens. So we can consider the ray passing through focus. After refraction, it will go parallel to the principal axis and the image will be formed here. So you know that to locate the image, minimum 2 rays we can draw. So you can draw another ray passing through optic center. Another ray passing through optic center you can draw, or another one more ray we can draw. Here the ray is passing through focus. So after refraction goes parallel to principal axis. Now I am drawing another ray. That ray is not passing through focus, but it is falling on the lower portion of the lens. You know that it's a converging lens. So all the light ray will converge us to a focal plane here. So the light ray will converge us to this point. So you can see that the final image is forming at where? At 2F. So you can see that the final image is forming at 2F. So here you will get the image when the upper portion of the lens is covered with a black paper, also no problem. You will get the full image, but the one important thing is what? Intensity or brightness of the image will reduce. When the upper portion of the lens is uncovered or we just remove that black paper, light can easily pass through the upper part. All light ray can pass through the upper part, and a bright image or intensity of the image will increase when it is not covered with a black paper. When it is covered with a black paper, you will get the same image, only the intensity of the image will reduce. So remember that thing. So once again listen. In the case of a convex lens, here object is at 2F, so image will form at 2F, and the nature of the image will be real and inverted. As per the question, upper half of the convex lens is covered with a black paper, so no light ray can pass through the upper part. Light ray can easily pass through the lower part. So you will get the image, but the intensity of the image will reduce. And when you uncover or the black paper, if you remove, all the light ray can pass through upper portion and a lower portion. You will get the same image, but the brightness of the image will increase, or bright image will form. Bright image will form when you remove that black paper. So I think all of you understood the A part of this question. Now we are going to the B part of the question. An object is placed at a distance of 30 centimeter from the optic center of a concave lens. Now the second question is based on a numerical. So here object is placed at a distance of 30 centimeter. You know that we need to apply sign convention. So object distance we can take it as u, and object distance always it will be minus, so minus 30 centimeter. From the optic center of a concave lens. So here the lens is a concave lens. So you need to remember that for a concave lens, focal length is negative. Focus is on the left side of the lens. So focal length given in the question 15 centimeter, and since it is a concave lens, we have to give a negative sign. So f is equal to minus 15 centimeter. Your question is, use lens formula to determine the distance of the image. So image distance we need to find out, and they are asking to use lens formula, and we can use the lens formula. You know that the lens formula 1 by f is equal to 1 by v minus 1 by u. So our aim is to find out image distance v. So keep this image distance v on the right side and take this object to left side. So our equation become what? 1 by v I am keeping on the right side. It will become 1 by v equal to 1 by f plus 1 by u. Now 1 by V equal to, we can substitute each values. F is minus 15. So 1 by minus 15 plus 1 by U is minus 30. 1 by minus 30. So we can take this negative sign to numerator. So 1 by V equal to, it become minus 1 by 15 minus 1 by 30. So we can see that LCM, we can take it as 30, or you can use the cross multiplication method, no problem. So now 1 by V equal to, I am taking the LCM as 30. So to make 30, this multiplying with the 2, here also multiplying with the 2, this already 30 is there, so into 1, into 1. So this become minus 2 minus 1 divided by 30. So you will get this is equal to minus 3 divided by 30, or the image distance V equal to its reciprocal minus 30 divided by 3 equal to minus 10 centimeter. So we got the image distance for the second question. Image distance is minus 10 centimeter. As we expected, you know that it's a concave lens. Concave lens image is forming on the left side of the lens. So you know that as per sign convention, left side is negative. So image distance is negative. So we can go to the next question. Now, next question is, draw a ray diagram to show the path of the refracted ray in each of the following cases. A ray of light is incident on a concave lens. So here the question is based on concave lens. Now your first question is, a ray of light parallel to principal axis of a concave lens. That ray diagram we need to draw. So you can see that both the questions are based on rules to draw the ray diagram. So we can consider first one. We can draw a concave lens. So you know that concave lens means a lens which is thicker at the ends and thinner at the middle or center. So let us consider a concave lens. Now as per the question, a ray coming. You can consider a concave lens. Now a ray coming parallel to principal axis. So let us consider, let this point as F1. Now a ray coming parallel to principal axis. You know that if a ray coming parallel to principal axis, as per our rules, after refraction it diverges from the principal focus. So this ray diverges away from the principal focus. So to get the get the meeting point, we can extend the ray backward and it will meet on focus. So this is the first ray diagram. A ray parallel to principal axis after refraction diverges away from the principal focus in the case of a concave lens. So your question is based on concave lens. Now second question also based on concave lens, and your question is based on again rule. A ray is directed towards the principal focus. So you know that a ray passing through focus after refraction goes parallel to principal axis. And if it is a convex lens, what will be happen? A ray coming parallel to principal axis after refraction converges to a fixed point. In the case of a convex lens, since it is a concave lens, it is diverges away from the fixed point. That fixed point is our principal focus. Now, second case, a ray is directed towards principal focus. So we can draw a concave lens. Now we are drawing a concave lens. So you know that if it is a convex lens, ray can easily passes through the focus. Actually can pass through the focus. But in concave lens, ray cannot actually direct it towards the focus. So let us consider focus here and let it be F1 or F2. Now I am drawing a ray. That ray is directed towards principal focus. I already told you ray cannot actually pass through the focus in the case of a concave lens. So this ray you can see that appears to pass through the focus, and after refraction it goes parallel to the principal axis. So this is the two ray diagrams as per our question, and this is based on rules to draw the ray diagram. You know that these are the two rules. A ray coming parallel to principal axis after refraction converges to a fixed point in the case of a convex lens and diverges away from a fixed point in the case of a concave lens. First rule. Second rule, a ray passing through focus after refraction goes parallel to principal axis. Now third rule, you know that a ray passing through optic center goes straight without any deviation. Now we will go to the next question. Second question is again a numerical based question. Now a 4 centimeter tall object is placed perpendicular to the principal axis of a convex lens. So here the question is based on convex lens. So what are the things given? A 4 centimeter tall object. So height of object given. You know that height of object is always positive. So we can write height of object HO equal to, given in the question, plus 4 centimeter. Now is placed perpendicular to the principal axis of a convex lens. So here the question is based on convex lens. Remember, dear students, always need to underline the given lens or mirror first. You know that sign convention is very important. So it's a convex lens based question, and convex lens, converging lens, and all the rays are converging toward right side of the lens. So focus is on the right side. That means focal length is positive as per sign convention. So focal length is equal to plus 24 centimeter as per sign convention. The distance of focal length given, distance of object from the lens is 16 centimeter. Object distance given. So we can take object distance u, and object is always on left side of the lens, and it is given 16 centimeter. So u equal to minus 16 centimeter. Now your question is to find the position and size of the image formed. Position of the image means you need to find out the image distance v, and size of image means you need to find out hi. So we can use, again, since the question is based on lens, we can use lens equation. You know, 1 by f is equal to 1 by v minus 1 by u. So our aim is to find out the image distance v. So keep this image distance v on the right side like our previous case, and take this u to left side. So now 1 by v equal to 1 by f plus 1 by u. Now we can substitute the values already we written here. So this equation become now 1 by v equal to 1 by f is 24 and plus 1 by u is minus 16. So now we can take that sign to numerator. So 1 by v equal to 1 by 24 plus into minus, this become plus into minus become minus. So 1 by 24 minus 1 by 16, and you can see that we can take the LCM as 48. So 24 into 2 is 48 into 2 here, to make it 48 into 3 here also into 3. So 2 minus 3 divided by 48. So v will be equal to, so this will be 2 minus 3, you know that, minus 1 by 48. So v equal to minus 48 centimeter. Now you can check the obtained answer is correct or not. Here you can see that focal length is 24 centimeter and object distance is 16 centimeter, means object is in between principal focus and optic center of a convex lens. So you know that what type of image will form? Nature will be virtual and direct, and the size of the image will be, you know that, enlarged image, and the image will form on the same side of the lens, that means left side. So v will be negative, the image distance will be negative. So we got the image distance v here. Now you need to find out height of image. We can use the magnification m equal to hi by ho equal to v by u equation. In that equation we can connect that hi divided by ho equal to v by u. So now hi we need to find out, that will be equal to v by u. This division, when it comes to right side, it become multiplication. Now all values we have, v we have, now right now we found out minus 48 divided by u we have minus 16 into ho we have 4. So you can see that this minus minus get cancels. So 48 by 16 become 3. So 3 into 4 equal to plus 12 centimeter. So as we expected, you know that height of image will be more than height of object, and since it's an enlarged image and since it's a virtual image, virtual erect image, our sign convention should be what? plus. Height of image here also we got plus. So this is the answer for the second question. I think all of you got the answer correctly. Now we are going to the next question. Now the next question is, draw a ray diagram to show the path of the reflected ray in each of the following cases. Now the question is based on reflection. A ray of light incident on a convex mirror. So here the ray of light is incident on a convex mirror parallel to principal axis and is directed towards the principal focus. So here also the question is based on rules to draw the ray diagram. So we will consider the first case. We need to draw a convex mirror. So I am drawing a convex mirror here. Convex mirror means you know that in this manner we can draw the mirror that curves outward. Now this is the principal axis. Now it's a rule based question. You know that a ray coming parallel to principal axis after reflection converges to a fixed point in the case of concave mirror and diverges away from a fixed point in the case of a convex mirror. That's the first rule. Second rule, you know that a ray passing through focus after reflection goes parallel to principal axis. Third rule, a ray passing through center of curvature retraces its path. Fourth rule, a ray incident obliquely towards the pole reflected obliquely by obeying laws of reflection. These are the four rules. Here the question is based on the first rule. Now a ray coming parallel to principal axis. Now this is a convex mirror. So a ray coming parallel to principal axis, you know that it's a diverging mirror. After reflection diverges from a fixed point, and that fixed point you know that our principal focus. So this is the ray diagram or diagram you need to draw for the first question. A ray coming parallel to principal axis after reflection diverges from the focus. Now second question, here ray is directed towards its principal focus. Now the second question also based on convex mirror. So we can consider a convex mirror like this. Now here you know that ray actually is not possible to pass through the focus. So here we can consider the case ray appears to pass through focus. So here this is the ray is directed towards the principal focus. So here you can see that this ray appears to pass through the focus. So after reflection, as per our rule, it goes parallel to the principal axis. So remember all the ray diagrams, rules, etc. you need to draw and study. So this is our two cases based on the first question and is based on convex mirror. Now we will go to the second question. Second question is again a numerical based question. Now a 1.5 centimeter tall candle flame. So given the height of object, here candle flame is our object, height of object given 1.5 centimeter. So HO equal to plus 1.5 centimeter given in the question, height of object is always positive. Placed perpendicular to the principal axis of a concave mirror. Now the question is based on concave mirror. You know that concave mirror is a converging mirror and the focal length is on the left side of the mirror. That means focal length is negative and image distance. If it is a real image, you know that it is also negative on the left side of the mirror. So now here concave mirror, focal length given 12 centimeter. So F is equal to minus 12 as per sign convention. I already told you it's a converging mirror. So all the light ray converges to left side. Left side means focal length is negative. Now if the distance of the flame from the pole of the mirror is 18 centimeter. Distance of the flame means object distance. Object distance given 18 centimeter. So U equal to minus 18 centimeter given in the question. U always negative. You know that always on the left side of the mirror or lens. Now use mirror formula to determine the position and size of the image. Like our previous case, position of the image means V you need to find out. Size of the image means HI you need to find out. So here we can use our mirror equation. Mirror equation is 1 by F is equal to 1 by V plus 1 by U. Dear students, it's very important. Underline the mirror or lens first. You know that a small change in the equation in mirror and lens, this minus, then it become lens equation. If this plus, then it become mirror equation. but that small change will make a large difference in your answer. So care it. It's very, very important. Study the equation properly, thoroughly. Now, our aim is to find out V. So we can keep the image distance V on the right side. So we can take this U to left side. So 1 by V equal to 1 by F minus 1 by U. So this will be 1 by V equal to, our focal length is minus 12. So 1 by minus 12 minus 1 by U is minus 18. So now we can take the sign to numerator. So 1 by V equal to, minus coming to numerator, minus 1 by 12. This minus into minus become plus 1 by 18. Here we can take the LCM as 36. So 1 by V equal to, LCM we are taking as 36. To make it 36 into 3. Here also into 3. To make it 36 into 2. Into 2. So this become minus 3 plus 2 by 36. That will be equal to minus 1 by 36. So you will get V equal to minus 36 centimeter. So our image is on the left side of the mirror. So negative sign indicate that image is on the left side of the mirror. Now our aim is to find out the height of image also. So we can find out the height of image. Now height of image, our mirror equation we have to use here. So HI by HO equal to minus V by U. So HI equal to minus V by U into HO. So that will be equal to minus V minus 36. So minus of minus 36 divided by U is minus 18 into HO given in the question plus 1.5. So you can see that this minus get cancelled. So minus 36 by 18 become minus 2. So minus 2 into 1.5 become minus 3 centimeter. So we will get the height of image or size of image as minus 3 centimeter as we expected. It's a image is on the left side. So left side images, you know that in the case of a concave mirror, real inverted, and the height of object is plus 1.5 and image height is 3, means height of image is more than height of object. So real inverted enlarged image. We can check the obtained answer correct or not. You can see that object distance is 18 and focal length is 12. Focal length is 12 means you know that C, the radius of curvature will be 24. So our object is between F and C. So image will be beyond C and it will be real inverted enlarged image, and we got the answer as expected. Now we will go to the next question. So now we can see the question. The variation of image distance V with object distance U for a convex lens. So here the question is based on a convex lens is given in the following observation table. Analyze it and answer the question that to follow. So you can see that a table with object distance given, image distance given. Without calculation, your first question is without calculation find the focal length of convex lens. So your question is to find out the focal length of convex lens, but we can use our 1 by F equal to 1 by V minus 1 by U equation. Other than that, we can easily find out. So justify your answer. So you can see that all the values of the distance, image distance. So here in the third case, you can see that object distance and image distance are same. You know that when object distance and image distance will be same in the case of a convex lens when object is at 2F. So here in the third case, object is at 2F. So object distance we can write it is actually 2F. So object is 2F means you know that 2F given as 50. So 2F 50 means our focal length F will be what? 50 divided by 2 equal to 25 centimeter. So 25 centimeter will be the focal length of this convex lens. We can easily find out using the ray diagram characteristics. So when the object is at 2F, you know that image is at 2F. That means object distance and image distance will be same only if the object kept at 2F in the case of a convex lens. So that's why 2F is 50 and F is equal to 25 centimeter. And it is plus, you know that since it is a convex lens and focal length as per sign convention plus 25 centimeter. Now, which observation is not correct? Why? And draw a ray diagram to find the position of the image formed for this position of the object. So, your next question is, in this table, one of the observation is wrong. You need to find out which observation is wrong. So we have now focal length we have. So we can consider this question is based on convex lens. So we can consider a convex lens like this. So this is our 0. Now let it be focus 25 centimeter. Let it be 50 centimeter. And similarly right side also we can keep 25 and 50 like this. Now we can consider each case. Now object distance is 150. Object distance is 150 means beyond 2f. So beyond 2f, if the object is kept, you know that image will be between f and 2f. Between f and 2f and is on the right side. Right side images are positive. So you can see that your first observation here it is plus, image distance is plus, that means right side, and it is between f and 2f. You can see that in between 25 and 50. So first observation is correct. Now second one again, object distance is 75. Object distance 75 means again beyond 2f. That means beyond 50 means beyond 2f. So image will be between f and 2f. That means it should be in between 25 and 50. You can see that 37.5 in between 25 and 50, and the sign is also plus because of right side. So this option is also correct, or this case also correct. Now the third one, already we know that object is at 2f. So image is at 2f. Object distance is minus, image distance is plus. That's already correct. Now fourth one, look here. 37.5. Object is 37.5 means in between f and a. Now the object is between f and 2f. So between f and 2f, you know that image will be beyond 2f. Beyond 2f, look the value, beyond 50, and right side plus. So this option also, or this case also correct. Now next case again 30 again between 25 and 50. That means between f and 2f. Between f and 2f, beyond 2f. Beyond 2f means beyond 50. Look here, beyond 50, 150, and as per sign convention right side plus, correct. Now the last case, look, object distance is minus 15. Minus 50 means object is in between focus and optic center. So if the object is kept between focus and optic center, you know that image should be on the left side of the lens, and it's a virtual erect enlarged image. Left side of the lens. Left side of the lens means as per sign convention we should be negative. So look, last option they given us positive. So this is the answer we need to, or we are finding, or we are checking. So this is our answer. So answer for the, which observation is not correct? Case 6. So answer is case 6. Observation not correct is case 6. So case 6 observation is not correct. All others are correct. Now why I already told you? Because object is in between focus and optic center. So image is on the same side of the lens, and image is on the same side of the lens mean as per sign convention it should be negative, but here it is given plus. So that's why it is wrong. Now your question is, draw a ray diagram to find the position of the image formed for this position of the object. That means you have to draw a ray diagram by keeping the object is in between focus and optic center. So now we can draw a ray diagram. So now we can draw a ray diagram here. We can consider a convex lens. So this is the principal axis. Now let it be f1 optic center. Let it be f2. Now we are keeping the object between focus and optic center. So now a ray coming parallel after refraction passes through the focus. Now I am drawing another ray passing through optic center. You can see that both the rays are diverging. These two rays will never meet on the right side. So to get the final image, we can extend the ray back. So you can see that the ray can be extended by dotted lines like this. So you can see that the image is formed on the same side of the lens. Now as per our case, here object distance is minus 15. So we can make this, actually this is 50, this is 0, and here we can make it as, sorry, this is 25, our focal length is 25, here it is 50, and object is kept at a minus 15. So this distance is 15 centimeter. This distance is 15 centimeter, and image is formed at a 37.5 centimeter. That means here this distance we can consider as 37.5 centimeter. So that's your question. Which observation is not correct? I already told you. Why reason also we discussed. Now draw a ray diagram to find the position of the image formed for this position of the object. So this is the ray diagram we need to draw. Now there is one more question. Find the approximate value of magnification for u equal to minus 30 centimeter. So the question is based on lens. You know that m is equal to v by u. Approximate value you need to find out. So m is equal to v divided by u for the u minus 30 in this case. So v plus 50. So 150 divided by minus 30, that will be equal to what? Minus 5. Yes. So this is the case we need to find out for magnification. U equal to minus 30 and v is plus 150. You know that convex lens magnification is v by u. So 150 divided by minus 30. So that will be minus 5. I think all of you got the answer. Now we will go to the next question. Define principal axis of a lens. Already you know that principal axis means of if this is a convex lens, an imaginary straight line passing through optic center and the focus is called what? Principal axis. In the case of concave lens also same manner. An imaginary straight line passing through optic center and focus is called what? Principal axis. Draw a ray diagram to show what happens when a ray of light parallel to the principal axis of a concave lens passes through it. So your question is based on concave lens. So we can consider a concave lens. So concave lens we can draw like this. Now this is the principal axis, that is an imaginary line passing through both optic center and a focus, principal focus. Now your question is when a ray of light parallel to principal axis of a concave lens passes through it. So we have to draw a ray coming parallel to principal axis. So you can see that when a ray coming parallel to principal axis, already the same model of question we discussed. After refraction, it diverges from the principal focus. So this is the ray diagram you need to draw. When a ray light parallel to the principal axis of a concave lens, you can see that after refraction diverges away from the principal focus. Now next question. The focal length of a concave lens given 20 centimeter. So the question is based on concave lens. You know that concave lens focus is on the left side of the lens. So we can consider as per sign convention focal length is given as minus 20 centimeter. At what distance from the lens should a 5 centimeter tall object, so height of object given HO equal to plus 5 centimeter, to be placed so that its image is formed at a distance of 15 centimeter. Here image distance given. Image distance given as 15 centimeter. You know that it's a concave lens, so image is forming on where? Left side of the lens. So as per sign convention, left side is negative. You know that concave lens only two cases. First case, when the object is at infinity, image is at focus on the left side. Second case, object anywhere on the principal axis. Between infinity and optic center, you will get the image on the same side of the lens, that means on the left side. So image distance always will be negative. So image distance V equal to minus 15 centimeter. Your question is to find out at what distance from the lens should an object be placed. That means object distance u you need to find out. Then also calculate the size of the image formed, means hi, height of image also you need to find out. Now we can use the lens equation. 1 by f is equal to 1 by v minus 1 by u. First our question is to find out u. So I am keeping this minus 1 by u here and taking this to here. So minus 1 by u equal to 1 by f minus 1 by v. Now minus 1 by u equal to, here f is minus 20. So 1 by minus 20 minus 1 by v, you can see that minus 15. All values we substituted. Now minus 1 by u equal to, this minus coming to numerator. So minus 1 by 20 minus minus become plus 1 by 15. Now we can consider, or we can take the LCM. LCM we can take it as 60. So minus 1 by u equal to 60. I am taking as LCM, or you can use the cross multiplication any method. So into 3 to make it 60. into 3, here into 4 to make it a 60. So minus 3 plus 4 by 60. So that will be equal to 4 minus 3, that is 1 by 60. But minus 1 by u is 1 by 60. So object distance u equal to what? Minus 60 centimeter. As we expected, object distance should be on the left side. So object distance will be negative. Now, there is one more question. You need to find out the height of image. So height of image we can find out using our equation hi by ho. Hi, height of image. The ratio of height of image to height of object, you know that it's known as magnification. So magnification related relation, hi by ho equal to v by u. So hi divided by ho is plus 5 equal to v by u. We have how much? Minus 15. Minus 15 divided by u we have minus 60. So hi equal to this minus minus get cancelled. Minus minus get cancelled. So this will be 15 divided by 60. Now hi will be this 5 also going to right side. So 5 into 15 divided by 60. So the equation become 5 into 15 divided by 60. You know that this we can divide 1 15 15 and 4 15 60. So this will be equal to 5 into 1, 5 divided by 4. So we have to divide 5 divided by 4, 1 4 4 and 5 minus 4 1 and will not go. So put a 0 in 10 2 4 8, then 10 minus 2 2 will not go 20. So 5 4 20. So the answer will be, height of image will be 1.25 centimeter. As we expected, height of object is plus 5 centimeter. It's a concave lens. You know that height of image will be plus since it is virtual and direct, and the size should be diminished and should be less than the object size. Object size is 5 and image size here you can see that 1.25 centimeter and it is plus also. So as per our expectation, we got the height of image as plus and it is less than the height of object. So it's a diminished image. So far we discussed important questions from the chapter light, reflection and refraction. I think all of you got it correctly. We'll meet again with another questions. Thank you.